Bam, there it goes. Hello, hello, hello. I lost my voice. Trying to get everything in the shot here. Maybe if I do this. Woo! There we go. Now, there. Thank you. Thank you, thank you. Hello. I'm Papa Bale, and we're experimenting with coils in series. Now, I had all these coils parallel. 1 second. Yeah. We started unprepared. Wouldn't be the first time, but there we go. Try and get my voice back a little bit. At least so you can hear me. So we got the 8 magnet rotor that is very heavy. It's 100% infill in the toroid. So it's got like flywheel capabilities. But this coil right here is 4 inches in diameter. So, and it's really thin, or in depth, thin in depth. So we're talking like maybe 20 turns around this axle per layer, and there's over 1,000 turns. I mean, it's like over 1.5 pounds copper. So what I'm getting at is I hooked these two in series, and then I threw this one on the end, and the power rating went through the roof. We were struggling to get, 15 volts to run the little motor over there. And this is a lot more than that. So I'm gonna let it speed up a little bit. See, we're already generating like 15. We don't even have any arcing at all on the switch. I'm all right. Thank you. Hello. How are we doing today? Awesome. 50 volts. Twenty-two volts on the motor, on the second motor. 23. Ooh. 24. 26. Look how bright that is compared to what it usually is. It's awesome. Hello, hello. Only on the fourth day of the week, Rage. And I'm glad you're interested too. Hello. Yeah, I'm not gay though. Still interested. Just not like that. There we go. Well, I don't have crystals that fit. See, that's the thing they don't put in the manual, is how to, shape the crystals without breaking them. So you build your entire ship around the shape of the crystal, right? Just to compensate for that. That's what happens. You gotta build your ship around the shape of the crystal. Because you can't cut it. And if you try and cut it, you're gonna break it. If it's the right crystal, that's exactly what's gonna happen. And that's why I like the shape, especially for like the really multifaceted crystals. Not just the hex crystals, but like those 24 sided shapes. The rhombicosi dodecahedrons, stuff like that. So like if a dodecagon is like a 12-sided shape or something, 12 faceted, then the rhombicosi dodecahedron is 36-sided or more. I think it's way more than that actually, because you gotta add triangles, hexagons, octagons. It's a mess of a shape, and it's immense, and it's real. It's geometrical. Because all those shapes, when you clip them together, they make another shape. There's no holes. Yeah, I love you guys. No, I got the whole wide world. Got the whole world. He's got the whole wide world. You all know how it goes. Alright, I'm going to bypass the switch. Probably only going to be able to get like 20 some odd volts into it, but so we take it from turn it into a conduit instead of a switch. I clip it on the same peg. $20 volts already. That's awesome. Okay, so I went from in the 20s down to like 17 volts. It's being consumed by the motor, but you still probably got enough to light this light off the cat bank. But I'm lighting it off a coil down there, and it's working out. Backed it too far out. That's awesome. It's running now, and it's not. It's 27 volts. It's awesome. 30 volts. It's got way more energy than it needs. Both of these lights are lit up like a Christmas tree. 35 volts. Wow, I love it. Getting way too hot though. Almost an amp drawn there. So if you move it offset position and have it 10% onset to match with the switch, you let a lot less energy through. I mean, an amperage. The voltage kind of stays the same, but the amperage changes a lot depending on where this coil's at. So, you know, you get right around 20 volts of output. You run that motor on 20 volts, wherever it's coming from, and it's going to go really fast. So, that one's working good. This one's working good. The lamp draw is a little high for me. It's 500 right now, milliamps. Might be that resistor. I cooked this resistor earlier, and it might be, yeah, it kind of smells like that. No, sir. This coil generates a lot of energy, and then having them all three in series generates that much more energy. The parallel doesn't work right. I need to have diodes for the AC connection to the cat bank, and I don't have the connections that want to even bother with that right now. So I'm running it in series, and it's working out a lot better, like in my favor. So I'm like, yes, that's the way we're going to do it. Even though there's probably a little bit more power running all this in parallel for the drive, it's not as good for the other side of generation. This is way better. The rotor, I think it's awesome too. I'm not trying to break any theories or any laws. I don't pay attention to them though. I mean, I'm not trying to break any laws, but I don't read up on them. The way I figure it, everybody else is reading up on it for me. But I know what's real and what's not. But that's what this is all about, like what's real. This is a brushless DC motor that's capable of generating electricity. Would I hook this up to my house? No, I would not do that. Not even if it was, no, I would never do that. You go pioneer that stuff yourself, man. I'm going to stick here with my table, and that's how I'm going to do that. Now, I don't know if anybody actually said to go do that, but it's like, yeah, don't say go do that. I'm not going to do that. That's not the purpose of this, to hook up to my house. There's no, it's perfect. It's a toy, really, that can generate electricity. If I left this running like this, probably not like this, but if it was on a little bit higher, I could leave it here and it would probably burn my house down. You know what I'm saying? If I didn't watch it, if I didn't know a little bit about what's going on here, it'd probably be dangerous. I don't care, man. True, not true, theories, I don't give a witchy teeth about the whole thing, man. About the movement, about any of it, dude. I don't care. I'm tired. I'm really tired. So, I mean, if we're going to have a political debate, I'm just going to shut it off. I mean, I know a few people that love to do that kind of stuff. I am not one of them. Okay? It's just got the wrong guy. You think that any of it, man, I don't, it's all on the fringe anyway. All of it doesn't make sense no matter how you plug it into this. Okay? But I'm not trying to break any laws. I'm not trying to do any of that kind of stuff. Whether they make sense or not, it doesn't matter. I'm not trying to do any of that. All right, the switch got stuck. Oh no. last time the switch got stuck, magnets went permanagnet, the electromagnets went permanagnet. And went flying across the table. It was awesome. Because the magnet gripped it because it was permanag and just flew through it. Because of how well that thing spins. It's got 8 neo cubes in it, and it's 100% infill on the outer rim. So it's really heavy on the outside, very light in the middle. It's maglev. It's got high-grade bearings on it. The fastest bearings I could find. It's missing one of the bearings in there on purpose to make it go faster. Now that's a very low amp draw. I'm going to start this up though. There it goes. Yeah, there's weight, inner length. It's pretty cool. All right. On a serious note, we're working with a dual switch, series connected coils. So this, and this are all hooked to the drive. In the same fashion they're hooked to the drive, they're also hooked to the energy generation. So we take the AC from the front, which is here, and we take it off the back, which is here, and it generates a buttload of power. This inductance coil, whoo, man, the power rating just went, it's like, this 24 gauge, it's about 1,000 turns, the center is about 1 inch in diameter, the coil is 4 inches in diameter, it's only 1 inch, 1/2 inch in depth though. I'm going to take this off here and get you guys a closer look. Maybe you guys can hear me better. All right, so let me clear my throat, or try. It hasn't been able to clear. That's what we're currently drawing. 45 volts and 4.6 amps, or 0.46 amps, my bad. 400 milliamps. Back the coil out to the fringe, and we're drawing that much. Yes, it is a magnetic generator. It's also a pulse motor, a brushless DC motor. It's also a motor running another motor, which is lighting a light bulb. So it's like a chain of events that continues till it hits the light, then it oscillates and goes back the other way. We get green plasma from our contact switch. It's just a small burst right now. Um, the, the bulb is supposed to be 1,000 watt metal halide bulb, but it's rated for 100 watts. No, I don't. I don't give a Weechee's heap about any theories, bro. Don't care about that stuff. I know a lot of people put a lot of effort into coming up or discovering those theories, but I don't know anything about it. I never took a physics class in my life, dude. I don't care. I'm an accountant. I have a I have a bachelor's degree with a major in accounting. I do not care about physics at all. You know? And I don't care that you think the earth is flat, Charlie. I don't care. I don't want to engage with that, dude. Oh man. Yeah, I know God's almighty. Yeah, they're going the other way around there. Goldrath. Goldrath. Yeah, any loans are gonna be coming my way, bruh. I wish I could just throw money around. I don't have any to do. So no. What's that thing on your face? It's awesome, man. It's the shiniest thing I've ever seen. Yeah, okay. Sorry, buddy. You come across like that, I don't even know what to say to you, man. Kind of walked right into that. I don't know, man. He said, "What's that thing on the table?" I mean, I don't know. It sounded kind of, yeah, zero tolerance, man. I'm sorry. That's where we're at right now. For all you guys who've got a sense of humor, I mean, I'm sorry. I really apologize. Thank you. I appreciate it. And, you know, it's kind of a let loose kind of day for me. I'm gonna try my hardest not to cuss. You know, I know that children do watch this show occasionally, so I'm gonna try and keep it clean for them. But yeah, man, and I'm probably gonna clip a few people that I don't want to because I'm on the rampage, man. I'm on the warpath, and I don't want to hurt anybody that doesn't deserve it. Oh yeah, man, this can go all night with the power the way it is. switch is bright. But it's like a 10% brightness. You get what I'm saying? I love having that coil on the end. It absorbs so much of the, like all the damage that could happen to all the components. It's great. It's awesome. I'm running this thing at like 50 volts with no resistance, added resistance at all. So it's like awesome, in my opinion. I'm playing with magnets and electricity. You guys can use your imaginations if you want to, but that's what I'm doing. I'm playing with magnets and electricity. I made a motor out of it. It's all 3D printed. The coil bobbins, the rotor. The only thing that isn't like, that I didn't make on this table is the magnets themselves. It's magleved already, dude. Big old toroid. You can kind of see it. Yes, Matthew, it's a time machine. Let's stop the rotor altogether and look at the inside, which is very hollow and light, fluffy in the middle. The bearings are hugging the shaft a little bit, but it's magleved, so it's not resting on anything. Maybe if I put a little bit of graphite powder on there, that would work. Let it rip. All right, let's turn her on. The other one already gripped up. It's already going again. It's awesome. It's the magnet. It's the mechanical switch, dude. There's nothing you can really do about that. You can remove it completely. Right there. That's it. The green fire. Yeah, the graphite. I just gotta find it. It's gotta be around here somewhere. But yeah, I'll throw some graphite on there. That should slick it up real good. All right, I want to show you guys something that I've also been working on. It's a lot smaller than this. It's in the other room. There he is. Master Kitty. Right here. I just got all 4 coils on each side of the thing connected in series. I got the 2N2222s on the way, and I'm going to hook up those to the coils and to this. 2 of these. And then this goes on here like this. And then I don't know really what I was thinking, but you know, it's an idea, it's a prototype. You know, you get this down, that could end up on a shelf somewhere. But yeah, it's really small, so it's not entirely easy to do. But these are the 10mm round magnets, very powerful in a short range. On the top, so it's got 2 plastic bearings that'll hold the plate above the magnets. But I think, honestly, I'm going to have to make another one where the shaft is a little bit longer because it's just too close for me to get a good spin off. But I'm going to, I'm going to try it because getting these magnets in here was extremely difficult.
5 miles.
Walk 5 miles, Paige?
Yeah.
Brilliant.
Tired. I ran a little bit in there.
So cool. See, look at how it's starting to, like, come toward the center. And then when it's ready to stop, it'll just lean over and stop, basically. I think that's a good design, especially with the magnets on the outside, bringing the weight, pushing it outwards. It's a top. A dreidel has 4 sides. This has more like 10. But yes, same concept. It is a 10-sided dreidel. And then it's supposed to be, or it should be, when this is all said and done, a powered dreidel. So cool. Yeah, man. Awesome. How are you doing? Here, let me bypass that switch real quick. It's gonna make noise up until a certain point though. We're gonna run just trigger coil right now. Wow, look at that. Look how bright that is. That's awesome. Hello. Did I just blow the transistor? Nope, there we go.
How long have we been live?
48 minutes.
48.
Yeah, I think it's simple. Some people don't think it's simple, but and it's multiple switches, dual switching. All right, I'm gonna incorporate the switch back into it. There we go. Thank you. Thank you, thank you. You know what? We're gonna run it with just the switch for a second. All right, so to do this, take this and we clip it to here. For good measure, we unclip that one. So there we go. Let's do it. See that start by itself? That's awesome. And we're getting enough juice off just the switch to light the light. Really brightly too. That's awesome. It is loud. Granted, that's a fact. But it doesn't have to be loud. It's not loud because of anything that's wrong with it. It's loud because it's using a mechanical switch. Well, it depends if there's any coils there or not. Usually it runs a lot farther without coils for a lot longer period of time without any abatement. And that's the truth. It just does. You spin it farther with your hand without power, and you can't without coils. You know, if you're gonna use coils, you might as well put power into it. Just because it's just gonna slow everything down if you're not putting power into them. But this will run for as long as I want it to. I never timed it yet. But like this one over here for runtime, this is magnetic suspension. This is it's being held up by magnetism. That's the axle that it's on. So it spin. This will spin, and the wheel will spin too. So let me spin this. No. No, dude, I don't know. Three-phase is awesome, but I don't build three-phase motors or generators or whatever's. It's too precise. I would lose interest too quickly. I like running it at 50 volts. The amperage varies depending on where this coil is. So there is no set amp input. Look at that baby go. So neat. All right. Now this rotor over here is really, really cool because the bottom of it is iron infused PLA. The top is carbon fiber PLA. But the magnets are being held in place by the iron infused PLA, and there's levitating on the toroid, and there's like no friction there. That's awesome. Hell yeah. Oh, I think the graphite was out there. Still spinning. And I think this is probably the least friction I have on any device because of how it's suspended on the magnetism. But then again, it can't run as a motor because it's so unstable. At least not one that is separate from itself. Let me put it that way. Maybe there was some in there, maybe not. It's kind of hard to tell. Awesome. Get them out.
I did.
Okay, good.
Here, Dad. Come here.
Got 2 of these bearings in here. They cost $24 a piece. Awesome. Should probably run that through a superconductor. That's what I think. Nope, that's going to be it. I got a... That's kind of hot.
I'm gonna watch something, so I'm gonna shut this.
Yeah, that's fine. Kids are monopole, yes. It is a Bedini-esque motor. It's got 8 magnets north facing out. So there's a big south field in the middle that's combined. And then the north outfield is nice too. But I'm going to do like one more thing here. Hello, hello. Hi. Awesome.
Yeah, no, I did not. I think I heard about that though. I didn't hear about him though. Hello, hello. God, I hope the future's got better components. Oh, I'm not worried about a damn thing, son. Thank you for trying to spread terror, SA. Oh yeah, that graphite's working great. Of course not. Look, dude, you're not funny. Okay? Hello. All right, it's a DC brushless motor generator. Right now I'm generating this much power off of this motor. It's about 23, 25 volts off of this system. It's being dual switched, okay? It's being run through all three coils and then through this magnetic induction switch. And at the same time, it's being, it dumps from the switch into this transistor. And then that's being switched by the trigger coil over there. So it's running through the switch and the transistor for the amplification from superconductivity. So bam. And then this motor is, alright, what a dick. What a fucking loser. No, I haven't tried anything but south facing outward currently. Or north out, my bad. I got a tri-filer coil right there though, so I could do that anytime. But those magnets are going to be a little bit harder to shift around, so I'm not doing that. I don't even think I'm going to do it at all. If I ever get enough balls to try and do a north-south configuration with the magnets being that close, I'll let you know. Boy, would I love to feed that guy to a shark. Seriously. Just watch that happen. That would be awesome. No, I admire and appraise the people that scavenge. I don't scavenge. If like I seriously and no, I don't have a garage, so no. This is my room, dude. I don't mess around like that in my room with like oily car parts. It's in my house, man. I wish I had another place to work because that would be awesome to experiment with stuff that already works. You know what I'm saying? That'd be great. But unfortunately, and I'm just a little upset about it. You know, I don't get to experiment with, you know, like I said, stuff that works. No, no, no. With your railgun and your cold fusion, just go away, man. I mean, I'm not building a weapon. I'm not building a bomb. I'm not building a weapon. Okay? Now my buddy, he was building a gun, a coil gun. And that's what it would be. It would be a coil gun. Because that's what's firing the rail is a coil. And no, 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 no. Yeah, and I mean, right away, that's where people go with this stuff because it's the path of least resistance. It's the path of least resistance, and that's exactly where everybody's head freaking goes because it's easy. There's like 3 or 4 things that this could actually be, you know, and one of them is a weapon. And it's not going to be a weapon, so that's automatically crossed off. But, you know, nobody like thinks beyond that. With the electrical and the frequency, I have a signal generator in my closet right here. You know, you can grow plants bigger. You can heal people. At least that's what I've heard. In resonant frequencies, you can heal tissues. I don't believe that. I've never seen it actually happen, but I've heard that you can actually you can make, you know, certain emotions just disappear. You know what I'm saying? Like if you want anger to go away in everybody so they have no fight left in them, then you can make that happen. Thanks, man. You get an A, an S, really. Now, granted, in the future, this may be the only thing left running. Alright, but it's been fun, and I feel good that I didn't have to, you know, make many people disappear. The one guy who said that I should, like, hook it up to my scrotum, I made him disappear. Okay, he's gone. I never have to deal with his fucking stupid ass again. Peace. Thank you, Ryan. Really appreciate it. I'm glad you weren't here to see that guy and what he said, man. But he said I should hook myself up to 50 volts. Just to, like, see if feel if it tingled or not. Yeah, you too, man. Peace. Bye now.